Let's review graphing an exponential and how that relates to its corresponding log graph. Because today we are going to graph logs. So remember, when we graph exponentials, we start at the point 0, 1, 1, and the base. And so we have just a basic exponential graph here. So we're going to plot the point 0, 1, and the base is 3. So in this case, we're going to do 1, 3, 3. So that is our parent graph. Our asymptote is at y equals 0 because there's no k, like having a plus 0 there. So we're going to dot in our asymptote. Sketch our graph. And then we can say with the domain, negative infinity to infinity, and the range can't be 0 to infinity. Now remember, our locator point is always this point right here, and when we shift it, wherever that point moves to. So our locator point for this parent graph is 0, 1. And we learned a shortcut for that, h a plus k. Then when we learned about logs, we looked at the exponential. We know that when we take this and we reflect it across the line y equals x, that is its inverse. So when you're looking at a log graph, if these are our starting points, when we have our x, y, when you do the log graph, you switch the x and y. So our starting points for a log graph would be 1, 0, base 1. So if I wanted to graph this corresponding log graph, I'm going to graph the point 1, 0, base, which is 3, 1. So in doing the log graph, I'm going to go 1, 0, 3, 1. And you can see that as we're reflecting that, those are in fact reflected over that line y equals x. We know that when we talked about this when we first were learning logs, the asymptote was x for this graph, x equals 0. So here's our asymptote here. Oh, let's use a different color. So we're going to have a vertical asymptote. We're going to have our graph. And that should look like the reflection of the red. It does. Remember, our range is the domain of the inverse. So our domain would be 0 to infinity. And if you look at the green, that makes sense. It stops here at 0. And our range, the green goes on forever and ever down here and up there, negative infinity. And when we talk about the locator point is this point right here, this 1, 0 point, wherever the 1, 0 point gets translated to. Now, so we looked at this, we've learned this, that we have the red and the green here, that when we graph a log, we graphed its inverse, we did the domain and range, we did x and y intercepts. We can do that. All right, so the y-intercept for the red is 0, 1. So that becomes your x-intercepts for the log, which happens to be our parent graph. And then when we were doing this, we were doing the look at the inverse equation, and that's when we learned about logs. So you have a graph of all of this in your notes. We did 2 to the x. Okay, so first we're going to start with the parent graph. Parent graph is log base 4 of x. Remember, this is your base with a log, that's your base. So in an exponential, we start at the point 1, 0, 0, 1, 1 base. In a log, we're going to start at 1, 0, base 1 for your parent graph. So my base is 4, 1. So 1, 0. I'm going to use X's. 1, 0, 4, 1. That's where we're going to start. Describe your translation. Okay. When we're looking at a log, we have very similar H's and K's just like you did before. So a log graph is y equals a log b of x minus h plus k. So remember, we always start with the h. Since it's a positive, that means we're going to go left 2. That's your h. Start with your h. Your a is this number out front. There's no a. So we're going to say that's 1. Y times 1. And then down 3. Your k. Now in an exponential, our asymptote was y equals k. In a log, your asymptote, remember it was an x earlier, is x equals h. So in this graph, my asymptote is going to be x equals -2. So that's the difference between logs and exponents. So let's take these points and let's translate them. All right, so I'm going to start here with this point right here. I'm going to go left 2. Y is 0, so 0 times anything is 0, so I'm right here. Down 3. 1, 2, so it puts me right here. Okay, so -1, -3. That's my locator point, wherever that point moves to, -1, -3. I'm going to take this point right here. We're going to go left 2, 1, 2. Y times 1 is 1, down 3, 1, 2. So this point's going to be right here. Okay. My asymptote is at x equals -2, so I'm going to put my -2 line right here. And we're going to sketch this graph. So that is the log graph. We can see that the domain x stops at -2. Okay, stops right here at this asymptote right here at -2. Parenthesis, can't be -2, -2 to infinity. You never can cross a vertical asymptote. Range, -infinity to infinity. Okay, so let's look at this next one. What are your starting points? We are going to start at 1, 0, base 1. Zero, 5, 1. Let's describe the translation. Right 3, y times 2, up 4. Because this is your A, this is your H, and this is your K. Asymptote is going to be x equals 3. Okay, so let's do our notations. We are going to go take this point right here. We are going to go right 3, 1, 2, 3. 0 times 2 is 0, up 4, 2, 3. So we should be right there. The locator point looks like it is 4, 4. Okay, let's take the second blue dot. absolute x. We're going to go right 3, 1, 2, 3. So we're right here. 1 times 2 is 2. So it means I'm going to go to the 2. And then from there, I'm going to go up 4. 1, 2, 3, 4. So this is at 8, 6. It looks like 8, 6. Asymptote is x equals 3. So I'm going to go x equals 3. And then we draw our graph. Domain we can see is from 3 to infinity. Range negative infinity to infinity. So I want you to think about, what if A was -2? Think about what that might look like. All right. So when graphing a log, you describe your translation, your h, a, and k, just like you do with all your other functions. Your parent graphs are the switch the x and y of the exponent graph, so 1, 0, base 1. Your asymptote is at x equals h, and you have your domain and range.